this video is going to be about the law of sines. Alright, the nice thing about the law of sines is that, like the law of cosines and all the other trig identities that we've learned so far, it is on your reference sheet. So, this law of sines. And the other thing about the law of sines is that it's used a lot in physics. So if you're in physics now, or you know that you're going to be taking physics, you're definitely going to use this. The law of cosines, I'm not too sure, but the law of sines definitely. And so the law of sines is actually pretty nice. Now, remember, it's sine as in a trig thing, not sine as in like the sign of the number. I'm just going to give you the law of sines right now, or you can look on your identity sheet. Then we're going to prove it, and it's a pretty quick and easy proof. And then we're going to do an example. All right, so what the law of sines tells us is that in a triangle ABC, we're always going to have certain proportions, or a certain ratio. The sine of angle A divided by the side of A is going to be equal to the sine of angle B divided by the side B, and that's going to be equal to the sine of angle C divided by the side C. Okay, so we can use this three different ways. We have two equal signs here, but we could kind of look at just this piece to figure stuff out, or we can look at just this piece to figure stuff out, or we can look at, now how am I going to do this? There we go. That piece to figure stuff out. Okay, so really we have a few different things that we can set up from this. Now, and maybe just a quick refresher, if I have triangle ABC, remember the capital letters are the angles, they're where your vertex are, and the side is always across from the capital letter. So if here is capital A, my angle with a capital A, across from it is going to be the side labeled little a. Here's my capital B, across from it is going to be the side labeled little b. Here's my capital C, across from it is going to be the side labeled little c. So what this is telling us is that the sine of this angle over this side is going to be equal to the sine of this angle divided by this side, which is also equal to the sine of this angle divided by this side. Okay? And this actually can be proved pretty quick and easy using the area formula that we know for a triangle. All right, that was in a previous video where we had in triangle, we'll use ABC again. We know that the area is equal to 1/2. We could have AB sine C. We could also have 1/2, it's a horrible equal sign. We can also have 1/2 BC sine A, or we could also have 1/2 AC sine B. Okay, to use this, we always needed two sides and the angle included. Okay, so like here we had AB sine C, that's because we had this side, and the angle in between. Okay, always two sides and the angle included. But it could be any two sides and the angle included. Okay, so now, as you can see, I have three things set equal to each other, which my end goal is to go from this up to this. Okay, what I'm going to do is I'm going to multiply everything by 2 to get rid of this 1/2 that's messing things up. All right, and I can do that because there are equations, so all I need to make sure I do is do it to every part of the equation so it balances. So I'm going to multiply here by 2, I'll multiply here by 2, and I'll multiply here by 2. So now I'm left with AB times the sine of C is equal to BC times the sine of A, which is equal to AC times the sine of B. Okay? Starting to look a little closer to what I have up there. Okay? The issue, for instance, if I look at right here, is that I'm not dividing by C yet, and I still have this AB up there. So what I'm going to do is I'm going to divide by ABC. Because if I do that, the A's and the B's cancel, and I'm left with sine C over C, which is right here. So that's awesome. Okay? But since I divided that by ABC, I have to divide everything by ABC, because this is an equation, and I have to do the same thing everywhere. But that's great, because here the B's and the C's cancel, and I'm left with sine A over A. And here the A's and the C's cancel, and I'm left with sine B over B. And boom, baby, there is the law of sines. Okay? I feel like the proofs we've been doing lately have been super quick. So there we go. Do you need to know how to prove it? Not necessarily. Is it cool to know and probably helpful? Yes. All right, but let's go to an example. In triangle ABC, we'll say A is equal to 10. The measure of angle A is equal to 30 degrees. And the measure of angle B is equal to 50 degrees. Let's find the length of side B to the nearest integer. So, always helpful, let's draw a picture. So here's my triangle, here's A, B, C. So here's my little a, here's my little b, here's my little c. Okay, little a is 10. I know that this angle right here is 30 degrees, and I know that this angle up here is 50 degrees. Okay, now, for starters, we should notice that with what I have right now, I cannot use the other things that I have, okay? Because, and what do I mean by that? I should probably use my words correctly. The two other formulas that we've learned so far, the area formula and the law of cosines, all need two sides and the angle included. And I don't have that right now. Okay, right now I have one side and two angles. Okay, and we do know that, angles in a triangle add up to 180. So I could figure out the measure of angle C. That's going to be 100 degrees. Okay, but that still doesn't help me if I wanted to use the two other formulas that we know, because those formulas, area and the law of cosines, need two sides and the angle included, and I only have one side. So now, this is the perfect time to use the law of sines. Now, if I look, I'll write out all pieces to the law of sines. Because even though this thing has 3 pieces, I don't need all 3 right now. Okay? I want to find B. So I definitely need this piece. Okay? Now looking at this, I know my angle C. I know diddly squat about the side of C. Okay? So it's not going to help me to use this piece over here, because that means I'm looking for B, but I don't know C. So that gives me 2 things that I don't know. Alright, so I don't want to use this one. If I look over at A, I know my angle at A, and I also know side of A. So I can fill in both things for that fraction. So that's definitely what I want to use. Okay, so you gotta actually do a little bit of thinking to figure out which two pieces of the law of sines that you need. So now we can just fill some stuff in. The sine of A is the same thing as the sine of 30. And little a is 10. The sine of B, well, that's the sine of 50. And little b is what I want. Now, just multiply. That's simple. Let me move the page. So I get b times the sine of 30 is equal to 10 times the sine of 50. Now, hopefully, we all can find the sine of 30 without a calculator because that's from a special right triangle. That's 1/2. But it's okay if you don't. Because to find b, we'll just divide both sides by the sine of 30. So 10 times the sine of 50 all over the sine of 30. And even though we all know the sine of 30 from special right triangles, we don't know the sine of 50 from special right triangles. So it's just easier to use your calculator. So if we type in 10 times the sine of 50, making sure we're in degree mode, you're going to get some crazy decimal. Leave that in your calculator the way it is, and then hit divide by the sine of 30. And we should get that b is, you should get 15.320, blah, blah, blah. But I wanted this to the nearest integer, so it's going to be 15. Okay, and that is it.